Hi, and welcome to this video on using the fundamental theorem of calculus. Now, when we do this problem, I'm going to be a little bit lazy. I'm going to redefine this integral as the integral from 1 to x to the fourth of little f of t dt. Now, we know the antiderivative of little f is big F, so we're going to evaluate big F of t from 1 to 4. When we do that, we get big F of Sorry, that's not a 4. It should be x to the fourth. Let me fix that. All right, there we go. X to the fourth minus big F of 1. Now remember, we want to find the derivative of this. So we're going to apply the derivative with respect to x of this, which means we have to apply the derivative with respect to x of our result, which means if we take the derivative of big F, we get little f. But since we have an embedded function, we need to use the chain rule and say, oh, that's going to be 4x to the third. When we take the derivative of this, remember this is a constant. It's a number we get when we plug in 1 to big F. So this is going to be 0. So the result we have here is 4x to the third times little f. Wait, little f was the same as secant. Okay, so secant, and we're going to plug in x to the fourth for that secant value, so secant of x to the fourth. And that is going to be the result when we take the derivative of the y. So dy dx is equal to this result. If we go back to the original function that we started with and we look at that a little bit, we're going to say, all right, the shortcut here is that we plug in the x to the fourth to the t, but remember we have to apply the chain rule. So we're going to get secant of x to the fourth times 4x to the third. And that is going to be the result when you take the derivative with respect to x of both sides, because the derivative and the integral are inverse operations. I hope this made sense. This gives you a nice option when you don't feel like doing all the nuts and bolts of the antiderivative.